Hello, dear learners. My name is Professor Jangu. Please, you're advised to like, comment, share this video. Please subscribe to this YouTube channel to motivate us to continue bringing up good mathematical content. Our discussion at this point is polynomial division. Precisely, we're going to see how to look for the quotient and the remainder terms. Let's go through the learning outcomes. By the end of this session, you should be able to understand what polynomials are, master the definition and the component of polynomials. You should also be able to apply long divisions, precisely learn the systematic process of polynomial division. You should also be able to know how to find the polynomial factors using division techniques. How can we define polynomials? Polynomials are expressions with variables raised to non-negative integer powers, and the terms are connected by addition or subtraction. The general formula for a given polynomial is given by f of x equals to an times x to the power n plus an minus 1 times x to the power n minus 1 plus an minus 2 times x to the power n minus 2 plus up to a1 times x to the power 1 plus a0, whereby n is an element of whole numbers. At this point, we will focus mostly on cubic polynomials. What are cubic polynomials? Cubic polynomials are polynomials whereby the highest degree of the variable is 3. The general form of a cubic polynomial is given by f of x equals to ax cubed plus bx squared plus cx plus d. To understand the long division process, we're going to consider a simple case of division with numbers. If you're asked to divide 13 by 2, what will this be equal to? Definitely you know the answer. 13 divided by 2 is equals to what? 6 remainder 1, right? 6 remainder 1. Alternatively, we can write it as 13 divided by 2 is equals to 6 plus 1 divided by 2. So 13 will be equals to 2 times 6 plus 1, whereby 13 is what we call the dividend. 2 is what we call the divisor. 6 is what we call the quotient. And 1 is the remainder. Based on this, we can bring up a rule for division. If we have an integer p divided by another integer, let's say d, the answer would be the quotient plus the remainder divided by the divisor d. Alternative, we can write it as p is equals to d, the divisor, times the quotient plus the remainder r, whereby the divisor is different from 0 and r can be greater than or equals to 0 but less than the divisor d. So based on this rule for division of numbers, we can bring up a rule for division of polynomials. Take note of the following. If a polynomial f of x divided by a polynomial d of x, then the answer is q of x with the remainder r of x. Alternative, we can write it as f of x equals to d of x times q of x plus r of x, whereby d of x is different from 0. This is also what we call methods of factorization of polynomial, which include long division and synthetic division. We will pick up the first point, and that will be our discussion of the next slide. So what's the long division process? You are encouraged to start off by setting up the division properly. You have to arrange the polynomials, both polynomials in descending order. You place the divisor outside the long division sign, while the dividend, you place it inside the long division sign. After that, you divide the first term of the dividend by the first term of the divisor. The next step will consist of multiplying and subtracting. So you have to multiply the quotient by the divisor, and next you have to subtract from the dividend. You now have to bring down the next term, and then you repeat the process until the reminder's degree is less than the divisor degree. Let's have a look at an example so that you can see how to apply the long division process on polynomials. Consider the polynomial x cubed plus 2x squared minus 5x plus 6 divided by the polynomial x minus 2. Our goal here is to find the quotient and the remainder. If you apply the technique that was mentioned so far in the previous slide, division, multiplying, subtracting, and then bringing down terms, you will definitely obtain the quotient will be x squared plus 4x plus 3 with the remainder 12. If you verify your answer by multiplying the divisor and the quotient plus the remainder, you should actually obtain the initial expression. Maybe that might sound still weird in your ears, but let's first look at how to apply this technique step by step. And I believe that after that, everything will be clear in your mind. Consider this next example. Use long division to obtain the quotient Q of x and the remainder R of x of the polynomial f of x equals to x cubed plus 2x squared plus 3x plus 7 with the divisor d of x equals to x plus 1. So remember, you first begin by writing your long division symbol. Inside the bracket, you put your what we call your dividend, the original polynomial x cubed in descending order, remember, from the highest power to the lowest power, plus 3x plus 7. And outside here, you have to put your divisor x plus 1. You now need to divide the first term, which is x cubed. Alternatively, you can ask yourself the question, what do you have to multiply x by? By what term do I have to multiply x to obtain x cubed? Definitely, I have to multiply it by x squared. So you multiply now x times x squared times x to obtain x cubed. You multiply x squared times 1 to obtain x squared. You now subtract x cubed minus x cubed is 0, so you just ignore. You consider the next term, 2x squared minus x squared. The answer here is x squared. You bring down the next term, which is 3x. Okay. You ask again the next question. What expression will you multiply x2 to obtain x squared? Definitely, you have to multiply it by plus x. You now multiply x times x, you're going to obtain x squared. After you multiply x times 1, you obtain plus x. You now subtract x squared minus x is just 0, or just ignore. 3x minus x, you obtain 2x. Okay, so remember, you can just ignore this term here. Now we bring down the next term, which is 7. You ask again the question, what do you have to multiply x with to obtain 2x? Definitely is plus 2, right? So you're going to say 2 times x to obtain 2x, and after that you multiply 2 times 1 to obtain 2. You subtract 2x minus 2x is 0. You just ignore it. So 7 minus 2, you're going to have 5. You stop there because there are no longer terms here. And also, the power of x here is 0. It is less than the power of x here, which is 1. So we can stop there. This implies our dividend f of x, which are original polynomial, can be written as the divisor x plus 1 times the quotient is the expression we've built up here, x squared plus x plus 2 plus our remainder 5. And you can verify your answer by expanding this. So if you say x times x squared, you're going to have x cubed. X times x, you obtain x squared. X times 2, you obtain 2x. You now multiply 1 times x, you obtain x squared. 1 times x, you obtain x. 1 times 2, you obtain 2 here, plus 5. If you collect the items, you're going to have x cubed. X squared plus x squared, you're going to have here 2x squared. 2x plus x, you're going to obtain 3x plus 7. And you obtain the original expression here. So it means our answer is correct. So that is how we go through the long division process for polynomials to obtain the quotient and the remainder terms. So what is the summary of our discussion? Throughout this discussion, we have learned how to do the long division process for polynomials. What did we learn? We learned that in an attempt to achieve this goal, we have to arrange the polynomial in descending order by placing the divisor outside the long division symbol and placing the dividend inside the long division symbol. After that, you follow the process. You divide the first term. After you multiply, after you subtract, and after that, you bring down the next term and you should be able to understand the result. After that, you have to verify your answer by multiplying the divisor by the quotient and adding the remainder to obtain the initial polynomial, which is the dividend. At this point, I believe that you know how to perform long division to obtain the remainder terms and the quotient terms for a polynomial. Thank you for following up this video. Please like, share, comment this video, and please subscribe to this YouTube channel to motivate the creation of such good mathematical content. Thank you. See you in the next upcoming video. Bye.